So say you're asked this problem right here. Find delta G naught given K equals 1.6 times 10 to the negative 10 and the temperature equals 25 degrees Celsius. The first thing you want to do is write down your equation that you're going to use. And then you're going to want to know what you want to plug in. So you put in the gas constant. You put in the temperature, but you need to remember to convert it to Kelvin. And then you do the natural log of the rate, K. And then when you plug it all in, you get 900 joules per mole. And with delta G not being the change in Gibbs free energy, R being the gas constant, T being temperature in Kelvin, and K being the constant.
So this example is asking you to calculate K at 25 degrees Celsius when delta H naught is equal to negative 23.5 kilojoules and delta S naught is equal to negative 168 joules per Kelvin. So first you want to use the equation delta G naught equals delta H naught minus T delta S naught because you're trying to solve for delta G naught. So first you plug in your values. Be sure to convert the units from delta H to match the units for delta S. So negative 23,500 joules minus the temperature. Be sure to convert this to Kelvin. So 298.15 Kelvin times negative 168 joules per Kelvin. When you calculate this out, delta G naught is equal to 26,589.2 joules per mole. So now that you've found delta G, your ultimate goal is to find K. So you use the equation delta G naught equals negative RT ln K. You plug in the value solved for delta G in the previous equation, and then you use the ideal gas constant for R. So that's 8.314 joules per Kelvin. And then the temperature is the same as the one we used in the previous problem. So 298.15 Kelvin. And then K is your unknown. So once you plug all of these values into your calculator, K is equal to 2.20 times 10 to the negative fifth. So why do we care about delta G anyway? Delta G naught is important because it allows you to know whether a reaction is thermodynamically favorable or not. On this graph, you see an exothermic reaction because delta G is negative and the products are favored. On this reaction, you see an endothermic reaction because the energy of the products is higher than the energy of the reactants. This reaction is not favorable. This allows you to draw a reaction diagram, such as these presented, that shows the relationship between the energy of your products and the energy of your reactants.
Thanks for watching!